In this example problem, we're going to be looking at a set of data and we're going to be calculating first the regression equation that we would use to make predictions based upon that data, and more importantly, the residuals. So no prediction is perfect. You are going to have an existing set of information, and the best thing you can do is make a regression equation where your results mirror as closely as possible the actual results that you have. And for our data set over here, we have 7 students. I'll make this a little bit bigger so we can see everything. There we go. We have 7 students, and for each student, we have how many hours they spent visiting a tutor in advance of their what seems to be ridiculously hard midterm, and the score that they got on their midterm. So we can use this information to predict how tutoring hours affects a student's performance on the test, or how X tutor hours makes Y, the actual raw test score, change. So to do so, we're just going to analyze the information that we have to determine the intercept and the slope. For the sake of making things simple right here, let's use those functions in Excel to determine our information. So A is the intercept. I can calculate the intercept of our existing data by using Excel's intercept function. The first thing it asks for is our known values of Y, which would be our actual raw test scores, and then our known values of X. And going through, our intercept is 22.43. Over here, we can do the same thing to find our B, which is our slope. So this equals the slope, open a parenthesis, of our known Y's, and comma, our known X's. So our regression equation is 22.43 plus 6.32 times X, which implies that a student that didn't go to tutoring at all would get about a 22 on the test. And then for every hour they spent with a tutor in advance of taking the test, it increased their score by about 6 points. So with that, we could make predictions to see how closely our regression equation is predicting a student's performance based upon their tutor hours. And for our predicted raw test score, and that's our Y hat because the hat means prediction, we can just fill in the X, how many hours a student actually went to a tutor, up here into this equation. So for Zach, his predicted test score would be equal to our A of 22.43 plus our B, our slope of 6.32, times his X value, which is how many hours Zach went to a tutor in advance of the test. And our information tells us that Zach actually went to the tutor for 1 hour. And our equation over here is going to predict that based upon the relationship we've observed between tutoring and performance, Zach should have got a 28.75 on the test. We can do the same thing over here for Alice. So Alice, same formula, just a different value of X. Hers is going to equal 22.43 plus 6.32 times Alice's X value, or Alice's tutor hours. And she went to a tutor for 2 hours. So 22.43 plus 6.32 times 2, Alice is predicted to have gotten a score of 35.07. And I'm just going to continue to do this all the way down the line for all of our different students. Because I don't want to type it in a million times, let's use absolute cell references to make stuff a little easier for us because I have the table for scores set up in a way that's going to allow us to do so. Avon's is going to equal the slope or the intercept of 22.43. And that's the number we keep clicking for every single student. So let's make that absolute by hitting the F4 key and putting the dollar signs in there, or it might be function in F4 at the same time, plus the slope. And again, we keep referencing that same cell, so that also wants to be absolute, times, and then this would be Yvonne's X value, or how many hours Yvonne went to a tutor. So she went to a tutor for 3 hours. And we'll click on that 3 and cell B6 that I have over here. I don't want to make that absolute because I want it to change to drag down one spot for each person that I have. I hit enter. Yvonne's is going to be a predicted score of 41.39, and now I can use this fill handle to fill in each respective student's value of X into this existing formula that we have up here. And we see that Brad is predicted to get a 47.71. Xavier was predicted to get a 54.04, Carlos a 60.36, and Ursula a 66.68. So none of our predictions are exactly on the number, but they're all pretty close. A few of them one student in particular I can see right here, Yvonne, outperformed expectations on the test, while Carlos, of all the students, substantially underperformed his expectations based on how much time he went to a tutor. And that difference between what our formula would have predicted and what they actually got is the residual. And the residual's value is y minus y hat for each student. So for Zach, he got a 30. Let's subtract from that his y hat, his predicted test score of 28.75. And Zach exceeded our formula's expectations by 1.25 points. For Alice, she got a 37. This regression equation predicted that she'd get a 35.07. Alice exceeded expectations by 1.93 points. And because I'm just continuing to do the same thing the whole way down the line, y minus y hat, I can fill handle for each student. Yvonne under exceeded what she should have got by 6.39 points. Brad, very close on that prediction, but our prediction had him 0.71 points higher than his actual score. For Xavier, he exceeded expectations by 1.96. Carlos is our underperformer in our data set, our overperformer, excuse me, in our data set. He exceeded expectations by 6.64 points, and Ursula under exceeded expectations by 4.68 points. But we have the residual for each one of our students in this class. And from that residual, we can kind of identify, is this thing making good predictions? Are our numbers close enough in here? And one way to do so is to make a graph of it, a residual plot, because you want your residuals, you're never going to be perfect, but you want them to be relatively in the same range all the way down the line. And the one thing you certainly don't want is your residuals getting either substantially larger or smaller as your X value goes up. So let's make a graph right here to look at what our residuals look like. And I'm going to use the insert graph idea here in Excel to make life easier on myself. The first thing that you can do is whenever you do this for a residual plot, you're going to need two things, your actual value of X and your residual related to that value of X. So I'm going to highlight my actual values of X over here. And then I'm going to hold down Control, scroll down a little bit, and highlight my values of E, if you will, my residual values. And when I do that, I can go up to Insert. In the Insert tab, this section over here says Charts. We can go grab us a chart that's going to be useful. I'm going to go to the Scatter Charts down here. And I'm going to grab the one in the top left, which is just our regular old scatter plot. And this gives us a graph like this. Looking at the information we have here compared to our points over there, the blue dots seem to be how many hours a student went to tutoring for. And that's not real useful for what we're looking at. We're only looking at how much they varied from our expectation. And that would be our residuals. And this one looks like it's about 1.25. It is. That's Zach's residual. This one looks like the residual is right about 2. It's about 1.93. That's Alice's residual. So the orange dots are representing each person's residual value. I don't need those blue dots. So what I'm going to do is click on the information on the bottom down here until this is all highlighted, my two series. I'm going to right click and I am going to select data. And when I do, this is going to pop up over here. First thing, series 1, those blue dots I don't want, so let me turn that check off. I'm going to go click on series 2 because somebody looking at this graph wouldn't know what series 2 means. You can edit it to change its name by clicking the edit button. And on the top, it says series name. What do we want to call it? We'll just call it residuals. And I'm going to hit OK. And this right here is, I mean, good enough for us to see what's going on in the data. And as we see right here, we've got residuals. 4 of the 7 of them are real close to our 0 line, which would be a perfect prediction. So that's pretty good. We don't have a particularly large data set, which means we don't know if this trend's going to continue. And I don't like the fact that our 2 of our larger residuals are on the higher values of X, but we don't have enough to say that there's something wrong with this. So it looks like we have a linear relationship right here. Our numbers aren't missing by anything crazy. Like we're not under predicting or over predicting somebody's score by like 30 points. Everything looks like it's okay to me. So I'm feeling all right about this residual plot. A couple of things that we can do if we want to right here, that this just triggers me for some reason that there's an 8 over here and it stops at 7. I don't know why it's doing that. So I can click on all of those numbers and that row over here. This is the number of hours that they went to a tutor for. I can go to Format Axis, and I can change my bounds to make the maximum 7 and X that out, and there. Now it looks better to me. So down here, create a residual plot for Excel. Let me just go drag that into the spot so we can look at it later. That's what our residuals look like, and we're looking like we're pretty close. So I did everything the long form way right here. So you can go through the steps to making a chart, to finding our residuals, etc. Excel can make this much easier on us using the data analysis tool pack. And just as a reminder right here, if you don't have it installed already, how you do so is you hit File, you go down to your options, which is hiding in the corner behind this little button over here. I can click on it. There we go. And you want to go to Add-ins. We want the analysis tool pack, and we want to manage it in Excel add-in. So I'm going to click the Go down here, and I'm going to click on Analysis Toolpack, so it's highlighted. I'm going to hit OK. And if that worked, when you go to the Data tab up on the top, you should have Data Analysis over here on the side. So for data analysis, instead of doing all the stuff, I can have this run regression for me. I'm going to make sure regression is highlighted. It is. I'm going to hit OK. And it's going to ask me for my input values. And for my input values over here, I was using this before, and the one annoying thing about this is it never deletes out what you had before. So I'm going to just move those out of there really fast. My Y range is going to be the Y range we use to find our intercept and our slope down here, our actual raw test scores. Our X range is going to be the actual amount of tutor hours they went through. Hold on 1 second. Let me make sure I have the headers in here to make stuff easier on me. There you go. So C3 to C10 for our Y range and B3 to B10 for my X range. I do have my labels highlighted now, so I want to make sure labels is on. And for my output range, I want to just throw it down here so it's not jumping over everything else. So let's make the output range start in cell A43. This is the most important thing. Down here, there's a section that says residuals. And what I can do is I can click on residuals, I can click on residual plot, and I can hit OK. And when I do that, all of the steps that we went through, Excel just calculated for me. As we can see right here, those two numbers, let's make them a different color so they really pop. Those two numbers are the same numbers, just not rounded off as we had in our regression equation for our intercept and our slope. If we scroll down a little farther, we can see the residuals right there for each individual. And going up, again, not rounded off, those are the exact same thing as the residuals that we had up here for each person. So instead of doing it all manually, we could have had Excel calculate us by having our residuals on in this graph. So time-consuming methodology, as long as you know where to grab the numbers from in your summary output that you get from Excel, you get some figures. So last talking point, is this a good predictor? Well, a good predictor is determined by your correlation of coefficient, or in this case, your coefficient of determination, your R squared. And our R squared right here is 0.905, which means 90% of the change we do believe in a student's test score is related to how many hours that they went to tutoring. It seems like a very good predictor for the information that we have to work with.